In this tutorial, we're going to run through the process to create and toolpath a spindle to cut on a CNC machine with a rotary axis. We're going to look at creating a component using the 2-rail sweep modeling function to create a basic shape, and then we're going to look at how we can add further shapes to the spindle using the Vector Unwrapper tool to create the spindle that you can see here. So let's go to File, Close. So let's start by creating a new file. So in the job setup form, we need to specify our job type. So we're going to use the rotary option here. We need to specify the size of our cylinder, where we need to input a length and a diameter. The units I want to work with are inches. We're going to switch to inches here. We're going to give this a length of 26 inches and then a diameter of 4 inches. Next, we need to specify our Z0 position, where we can position that on the cylinder surface, as indicated by this red dot here, or we could set that to the cylinder axis, again indicated by that red dot here. Now, this is going to be the most reliable choice, as it's much harder to set your Z0 off the outside edge of your cylinder, because that requires your cylinder to be a perfect circle for that to be correct. And so the cylinder axis is the equivalent in the software to setting your material to the bottom of the block to be Z0 on a regular 3-axis job. XY datum position, we're going to set that to the lower left hand corner, and then we need to specify our cylinder orientation. And this is where we choose to wrap the Y values around the rotary axis or the X values around the rotary axis. And this really is dependent on the orientation of your CNC's rotary axis. So you'll need to check with the manufacturer or look at your CNC in order to see which setup you have. And so for demonstration purposes, we're going to keep the linear axis along X and wrap the Y values. Okay, so then what we're going to do is we're going to set our modeling resolution, and we're going to set that so that's very high, and then we can simply go ahead and press OK. And so the software will create the correct size job for us. Now, it's important to note here that whenever we are working in Aspire, we're always working in a 3-axis environment. So we're going to model the part and create the toolpaths in standard XYZ 3-axis orientation. And then we can see what the part will look like in a wrapped view in the 3D view. But the only time that wrapping will occur is when we choose a post processor that has that wrapping ability built into it that's appropriate to our CNC, and then we save the toolpaths. Until then, the software only considers this as a 3-axis job, where we have the ability to view it as if it was wrapped around a cylinder. So let's just maximize the 2D view. I'm going to use this option here to zoom active view to our drawing limits. Now, when we set up a rotary job, we also get a couple of layers that are automatically created along with some vectors. So if we go to the view toolbar at the top, we're going to go to our layers bar here, then click on that to take a look at the layers that we've got. Okay, so we have a 0 plane layer, we've got an empty layer, which is our currently active layer here. We've got a 2-rail sweep layer, and if we just double click on the page there, we can see the vectors. So we've got one vector here, we have one vector here, and these are useful to creating a 2-rail sweep, which we are going to take advantage of in a moment. Then we have a layer here called bounding box, and if we switch on the visibility of that, we can see we've got this red vector that represents our job space. Now, I don't need that for this example, so we're actually going to look at deleting that. So we'll just click on there to delete. We'll delete this, and we're just going to delete that data as we don't need it. So we're going to start by importing a vector from a different file, and this vector represents the basic profile for the shape we are going to wrap. So we're going to go over into the import vectors folder, and then from the project folder we're going to open rotary profile.eps. Okay, so this vector represents the basic profile for the shape that we want to wrap. I've pre-drew this in the software before exporting it, and when you create a wrapped part, your first job is to sketch out the shape of the profile that you want. And now we've already done that. We can see that vector here. So we're just going to take that vector and using the down arrow key, I'm just going to move that outside of our work area just to keep our work area empty. So now I have all of the vectors that I need to create a simple swept shape. So we can look at modeling that and then look at running some toolpaths. So before we create the component, we're just going to look at organizing our layers. So let's go over into our layer tab here. Okay, so you can see we've got that zero plane layer. We also have a zero plane component that's automatically created when we open up a Rotary job. So we're just going to go in here and we're actually just going to delete it. So we're just going to delete this. We're going to delete all of that data as well. Okay, so layer 1, we're actually just going to rename that, and we're going to right click to use the rename option, and we're just going to call this one components. And so any components that I create now, as this is the active layer, will be added, the grayscales for those components will be added to this particular layer, and with that being at the top, it means that it won't obscure any vectors that we create in the layers below it. Okay, so we're just going to rename this import layer. So this is from the EPS, this vector that we imported here. So we're just going to rename that one. So it's a little bit more simple. So we'll just call that one Rotary Profile. So we'll delete that. Then we'll just get rid of that EPS there, just so it's a little bit more simple in our list. So now let's take a look at creating the model for our spindle. So we're going to go and select the components layer to make that the active layer. We're going to make use of the vectors that we have on the 2-rail sweep rails layer, along with the vectors that we imported to create our shape. So let's go into the modeling tab. We're going to use the 2-rail sweep tool. So we're going to click on that and that will open that up. So we're going to select our rails by selecting them and then pressing Shift to select the second one, and then we'll use this option here to use selection, and that will transform those vectors into drive rails. And all we need to do now is select our profile, so you can just simply select that profile there. I'm just going to uncheck these options, scale cross-section with width and sweep between spans. We're also going to uncheck this option to scale to an exact height, and then we can simply give that a name. So we'll just call that one main profile, like so. And then we can simply go ahead and press apply. And then we can take a look at our part. So we're looking at this currently in the 2D view. So let's switch over to the 3D view. We'll just tile our windows so we can take a look at the part there. And we'll just use this option here just to toggle the visibility of our material block. So you can see how quickly and easy it was to create this shape that we've got here. Just a simple case of doing a 2-rail sweep with a profile. And so at this stage, we could go on to create the 3D roughing and the 3D finishing toolpaths, and that would all we would need to do to cut this part out. Now, as you can see from the model, we have a number of flat areas. We've got this area here, we've got here, and we've got this area over here. And so to get best results in those areas, perhaps a 2D profile toolpath would be beneficial. Now, we're not going to worry about this area over here, as I plan to change the shape of this shortly in this tutorial. But before we calculate the toolpaths, let's create some boundaries for the 2D toolpaths, just to be a little bit more efficient in how we actually calculate them. So we're just going to close out of the 2-rail sweep here, and then we're just going to maximize our 2D view. Then we'll use this option here to zoom active view to our drawing limits. And so to keep our part organised, let's go to our Layers tab. We'll add in a new layer. We're just going to call this one 2D Pocket, like so. Make sure that's the active layer. And we'll go into the Drawing tab. Okay, so we're specifically looking at this area here. So this part, this dark grey area. Also looking at this flat that we've got here, and then this flat that we've got over there. So we can see I currently have my Smart Snapping option switched on. That's going to help me draw out some of these flat shapes. So we're going to go and use the Draw Rectangle tool. Okay, so we're just going to click on that. And what we're going to do is we're just going to guide this up and we're going to snap that in place. You can see I'm also snapping to the bottom of the job there. And I'm going to click, and then we can simply ensure that we're snapping to this point here. So I'm just dragging that along and we can see that we're snapped to the top. We're still in line. I can simply let go, and there is our first flat. So moving on over, okay, so you want to wake up this point here, and you can see I'm now snapped to the corner there, and so I can click and then I can bring that up. Let's just wake this point up. So by waking a point up, you just simply need to hover over it just to activate that. You can see I've got that line to follow, which is very useful. We're now snapping to the top bounds of our job, so I can click and there's our vector there. And then finally want to snap to create a shape that represents this flat area. So we'll just wake that point up there, okay, so like so, and then we can see we've got a snap there, so we're just going to drag that up to the top. We're snapping in place, and there's our vectors there, so we can close out. And so here we have 3 rectangular vectors that represent the 2D areas of our part. So whilst we're doing this, I think it's also a good idea for us to create vectors that represent the 3D areas as well. So going up to our view toolbar, we're going to go to our Layers tab and we're going to add in a new layer. We're going to call this one 3D Boundary, like so. And so just to help us differentiate the 2D pocket and 3D boundary vectors, we're actually going to look at altering the colours of these layers. Okay, so what we'll do is we'll just put the 2D pocket and we'll go into an orange colour, and then for the 3D boundary we'll just go with a green colour here. Make sure that the 3D boundary is the active layer, so any vectors that we create now will be added to that layer. Okay, so let's go back into the Draw a Rectangle tool, and then here we're simply just going to snap from this point here to this point over here, and then this point here to this point over here. Then we can close out, and here we have the 2 sets of boundaries for the 3D and the 2D elements of our part. Now before we go and create the toolpaths, one thing that we should do is look at increasing the height of the pocket vectors to ensure that the centre of the tool comes past the edge, so that we don't have any kind of seam effect where the part actually wraps around and joins up. So we're just going to go into our layers bar here, and we're going to double click on the page for the 2D pocket layer, and by double clicking on that it will select all of those vectors for us, in which case we can go into the transform objects tool, and if we click on that, this is where we're able to alter the size here. Okay, so we're just going to use this option here to unlink XY, as we only want to change the height of these vectors. We're just going to alter the height here, and we're going to make that 13. And then we can simply go ahead and press apply, and we can see that those vectors have all changed here. And so now when we come to run our pocket toolpath, the pocket toolpath is going to run over up to the edges of those vectors, and that will eliminate the seam effects that we could potentially get from the round tool hitting the edge of our part if we had left those vectors as they were. Now we don't actually need to do this for the 3D boundaries, as the centre of the tool will actually touch the edges of the vector boundaries, and so we won't be creating the seam effect there. Okay, so we'll just close out here. Okay, so we've got pretty much everything set up in terms of the vectors and the model itself. So now we can switch over to the toolpath. So let's use that option here to switch to the toolpath commands. Okay, so the first and most important thing we need to do is check over our material setup. So we're going to use the set option here. Okay, so the diameter is 4 inches, our XY datum position is in the lower left hand corner. We're setting the Z0 position to the centre of the cylinder. Next up, we need to specify the model position in material. Now, my model thickness is 2 inches, which matches the same as our diameter of our stock that we're using. Now, if your model was less than the thickness of the material, then you'd need to position the model within the cylinder, leaving a gap either outside or inside of the model. Next, we need to specify the rapid Z gaps above the material. So we'll just go with a clearance of 0.5 there, and we'll go with a plunge here of 1/4 of an inch. So then you want to check over your home and start position. So we've got X0, Y0, and then we want to specify the Z gap above the material. So this must be at least half the thickness of your cylinder plus the highest of our rapid Z gap. So we can make sure that we clear the block. So we're just going to set that to 0.25 there. And once you're happy, we can go ahead and press OK. So the first toolpath we're going to look at creating is a 3D roughen toolpath to hug out the majority of the material on the 3D parts. So we're going to go into our layers bar, and we're just going to double click on the 3D boundary layer, and you'll see that that's now selected the vectors on that layer. And so if we go into the 3D roughen toolpath, we can start to look at using these vectors to apply 3D roughen toolpath to. So we're going to start by selecting our tool. I can see I currently have a 1/4 inch end mill selected here. That is the tool that I'd like to use. Now we just want to check for this particular toolpath the settings for this tool. So we're going to use the edit option here. So here we have a diameter of 1/4 of an inch and pass depth of 0.1. I'm actually going to increase this pass depth. I'm going to increase that to 1/4 of an inch. And so we can OK that, and that will only apply that to this tool for this particular toolpath that we're creating. And it won't actually affect the settings of the tool that we currently have stored within our tool database. So moving on down, we need to specify our machine limit boundary. So we're going to use the selected vectors option, whereby we've got those vectors currently selected. We're not going to apply an offset, as the center of the tool is going to go right up to the edge of our vector there, and that's exactly what we want it to do. And then next up, we need to specify a machining allowance. So for the allowance, we're just going to go with 0.05 here. So this is where we're just going to leave some virtual skin on here for the finish tool to come in and cut at that. So it just keeps the roughing tool away from the finished surface of our part. Next up, we need to specify a roughing strategy. So we're going to do this in a Z-level strategy. So we need to specify the raster angle. So we're going to leave this set to 0 degrees, and this will cut along the x-axis before stepping over. And this direction is very important when doing a rotary setup. So when we raster at 0 degrees, the tool will cut along the x-axis, and then there will be a short rotary move, which is the equivalent of the step over, and then it will raster back again. If you wanted to raster along the y-axis, then we'd enter 90 degrees in here, so that the toolpath was going in this direction, and that would be the equivalent of the part spinning all the way around, with the tool then stepping over in X and then spinning all the way around again. And so it all depends on how you want to machine this. For most people's setup, you're probably going to set your raster angle to 0 degrees so it rasters along the x-axis. So we're going to ensure we do a profile pass last, and then we're going to set the order to do that to depth first. So it's going to machine everything in the one region first before it then moves on to the next region. Okay, so we simply give that a name. So in this case, we're just going to call this one 3D roughing, and then we could simply go ahead and press calculate, and then the software will automatically open up the preview toolpath form, and we can maximize the 3D view there. So let's go ahead and preview our toolpath here. Now you would have noticed for a split second there that the software unwrapped our part as it was calculating the toolpath preview, even though we're previewing this in a wrapped environment. Now that the software has calculated that preview, the software still thinks of this as a flat 3-axis toolpath. It will be the compatible post-processor that will exchange the Y values for the rotary axis movements. So with the wrapped toggle option switched on, I'm viewing this preview as if it were being wrapped, and I can still view our part in a 3-axis view by using the toggle wrapped view option. Okay, so I'm happy with what we've got there, so we'll just close out. So now what we're going to do is we're going to look at calculating the pockets for all of the flat areas. And so you'll remember that the flat areas we're looking at are here, here, and then this flat area here. So we need to look at taking a couple of measurements to help us determine what depth we need to cut down to. So let's switch back over to the drawing tab. We're going to go into the 2D view. We'll use this option here to zoom active view to our drawing limits. So we're going to go into the drawing tab. We're going to look at using this measure tool here. We're going to click on that. That's going to open up the measure tool. So here we want to measure between 2 points. So we're going to click on that option there. We're going to measure from this point here. We know that that is the top surface of our spindle. So that's at the very edge of our spindle. So we're going to click there. Then we're just going to go down, and then we're just going to click here. We can see the distance there is 1.075. And so knowing that this point here is equal to the outside of my cylinder, we can actually use this measurement to create our pocket depth. So at 1.075, we're just going to make a note of that, and that's the depth of cut for this particular pocket. So the next one, we're going to click at this same point again, and this time we're just going to bring this tool over to the flat over here, and we're just going to snap to this point over here, whereby we can see the Y distance here is 1.25. And so I know that the pocket for this area here, we need to set the cut depth for that to be at 1.25. And then finally, we need to take the next measurement. So we're going to click at this point here, and then just click at the end point over there. We can see that we've got a Y distance here of 1.5. So again, I'll make a note of that, and that's how far down we're going to create our pocket for this section over here. So now that we've made a note of all of those values, we can now create the 3 pocket toolpaths, and we can do those at the different depths that we measured. Now I could use a 3D toolpath to cut the entire part out, but it's much more efficient to use 2D toolpaths for what is essentially flat areas, and then we can limit the 3D toolpaths to only those 3D areas. So let's just close out here. We're going to switch back over to the toolpaths tab. So let's go ahead and select our vector. We're going to go into the pocket toolpath to create our first pocket. So we're going to click in there to open up that form. So we're going to specify a start depth of 0, the cut depth, looking at my notes that I've written down from those measurements, we're cutting down 1.075 here, and that's how far it's going to cut down. So that's the measurement that we measured from this point here to this point here. Okay, we've got the 1/4 inch end mill in there. Let's use the edit option to check over our pass depth. We're going to increase that pass to 1/4 inch. We'll go ahead and press OK. It's going to machine that in 5 passes. We're going to do that in a raster strategy where then we have the raster angle at 0. We're going to run a profile pass last. Call that one pocket 1. Go ahead and press calculate. Okay, so there's that one there. And we can just simply go ahead and preview that. And then we can close out. Then we can go back into the pocket toolpath form, just tile our windows here. Now we'll select the next vector for us to use. And so the cut depth we need to apply to this one, as we measured, is 1 1/4. Okay, and then we're just going to go the exact same settings, press calculate here, we'll preview that. You can see what that looks like. And then we can close out. Back into the pocket toolpath where we can select our final vector here and then specify the third cut depth, which is 1.5. So that's the measurement we got from this point here to the surface of our cylinder over here. Exactly the same settings as before. We could go ahead and press calculate, and then we can simply preview that toolpath here. So we've got 3 pocket toolpaths, nothing too exciting there as we're just cutting away at 3 flat levels. So let's just put that back in Z. And then we'll just switch on our wrapped view to take a look at that in this view as well. Okay, so that's pretty much our part so far. So now what we can do is we can start to think about creating the 3D finish toolpaths. So let's just close out of the preview toolpaths form. And then we're going to go into the 3D finish toolpath. Okay, we're just going to deselect the vector there. We're going to select this vector here. Hold down Shift and we're going to select this vector here. So these are the vectors that represent our 3D areas. So we can see we have an 1/8 inch ball nose in our tool list. Now I'm going to remove that, as the tool I'd like to use is a 1/4 inch ball nose. So we're going to use the select option to open up the tool database, select that 1/4 inch ball nose, ensure that the settings are safe and appropriate for your particular machine. And so we're going to go with that 1/4 inch ball nose there. In terms of the machine and limit boundary, we are using the selected vectors that we have here, where we're going to have a boundary offset of 0. Okay, we do not want that tool rolling past the edge of our vectors. And we can move on down, we can specify how we want to machine this, whether that's in an offset strategy or in a raster strategy. Now in this case, we're going to do this in a raster strategy. We're going to raster along the x-axis, so we're going to set the raster angle here to be at 0. Okay, and then we can just give that a name. We'll call that 3D finish, and then we can simply go ahead and press calculate, and the software will just take a moment to calculate that for us. Okay, and then what we can do is we can simply go ahead and preview that toolpath. Okay, so there is our finished part, and that's looking pretty good. Okay, and so if we maximize the 3D view, this is exactly what we'd get if we were to output these toolpaths on our rotary axis. And so at this stage, we could simply go ahead and save out those toolpaths. And so we've seen the process for using a simple swept vector in order for us to create the 3D shape where we calculated the relevant 2D and 3D toolpaths to cut it out. Now I'd like to take this and create a variation of this, where I'd like to create a box shape for this top section over here and an octagonal shape for this bulbous part that we've got here. And so I'm going to show you how to create these shapes on top of the model that we already have. And so to do this, it will require us to use the Vector Unwrapper tool. So let's just close out of the Preview Toolpaths form. We're going to switch over to our Drawing tab. Now, the Vector Unwrapper tool can be found in the Drawing tab within the Rotary setup under Transform Objects. So you're only going to see this if you're in a Rotary job. So the vector unwrapper requires me to draw a vector which represents the cross section as I want to see the object once it's been wrapped. So to do this, I need to look at drawing a square that represents this area here to create that box shape. So if I look down this axis, so I've got to imagine we're just creating a box that's going to sit in the centre of the cylinder. So that's what the shape that we need to draw. And so we need to draw a box that's going to represent this area here. And when we unwrap that, we'll get the correct shape. And so over here, we're going to look at creating an octagonal shape. So to help us draw out these shapes, we just need to get a few more measurements. So let's go into the 2D view. I'm just going to use this option here to zoom active view to our drawing limits. So we're going to start by looking at the square shape, and we want the square box shape to go into this area here. And so what we're going to do is we're going to go back into the measure tool. Okay, so this time we're actually going to measure from the centre of our cylinder. We're going to measure up to the highest point that we've currently got on this vector here, on the area that represents the area we want to kind of box off. So if I click there, we can see that we have a Y distance here of 1.4. And so that's that vertical distance that we've got from the centre going to the face of our box that we're going to create. Okay, so that's 1.4, but we're going to need to double that to create the other portion. So this is just half of our cylinder here. So really we need a square that is 2.8 inches across the flat. So we're just going to double that value that we've measured there. Okay, so now we can look at measuring the distance for the octagonal height. Okay, so we need to take two measurements here. We need to take one at the lowest point, which is here, and then one at the highest point, which is over here. And so we're going to click over here. We're going to go to the lowest height, which if we click in there, we can see we have a Y distance of 0.75. So I'm going to need an octagon that is 1.5 across in this area. And then if we just click at the center point here, and we're going to find the highest point of this curve here, and if we click there, we can see that we have a Y distance of 1.75, and so again we'd double that for the full distance, which would be 3.5. And so you'll see the effect of these measurements in a moment when we come to create the shapes. So I've took note of all the measurements. Okay, so we've got between here and here, we've got 1.4, so I need to create a box or a square that's 2.8 across. We then need to create an octagon at its lowest point. It's going to be 0.75, and so again we need to double that, so it's 1.5 across, and then the highest point we measured that at 1.75, and so we need to create an octagon that is 3.5. Okay, so we'll just close out here. And so to start, we're going to draw a square that is 2.8 by 2.8. So we're going to go into the Draw Rectangle tool, and we're just going to put in a width of 2.8 and a height here of 2.8 there. And then we can just click to accept that, and then we can simply close out. And so with this vector, all we then do is go over into the Vector Unwrapper tool. So first we have to choose the centre of rotation. Now by default it will use the centre of the contour. This is the vector we selected to unwrap. And you'll see that it displays a circle and a crosshair. So the circle represents my cylinder and the crosshair represents the cylinder axis. So let's just zoom in. So we can see the axis is in the centre of my square, and we can see I have a little bit of clearance with the box cross section in order for it to fit into the cylinder when we create the toolpaths for this. Now if I wanted to, I can make adjustments to the vector. I want to unwrap, I could make it smaller. I can move the Unwrapper tool to a position that I like, and you'll see that it can snap to geometry also. So let's just undo that. And we're just going to use the option here to zoom active view to our drawing limits. Now there are two further options in the form. We have Center of Workspace, and this is useful if the vector that you want to unwrap is in the center of your job. And then there is Custom Point, where you can position the unwrapper wherever you like relative to the current contour's center, so for the box here. And so you could type in values and you'll see that it moves. Or we could just manually move that by clicking on the center, and then we can move it to a position in the job. And this is particularly useful if you don't want the linear axis in the center of the vector that you want to unwrap. So in my case, I want to unwrap the box with the cylinder axis going through the center of the square. So we're going to use the center of contour option. And then the final option I have here is to simplify the unwrapped vector. Now when we come to unwrap the vector, by default it will create a vector that is made up of straight lines only. And so using the simplify option, the software will do its best to auto-fit some Bezier spans to the unwrapped vector. And this is particularly beneficial for when we come to create a model using the unwrapped vector, because if the vectors are smooth, then ultimately our model will be too. So we're going to select this option to simplify my unwrapped vector. So then we can simply apply that, and then we can close out of the form here. So you can see we've got the unwrapped vector positioned in the center of our job there. And if we take that, we can just look at rotating that. So if I press 9 on the keyboard, that will rotate my part in increments of 45 degrees. Okay, so we're just going to take that and we're just going to move it down out the way for now over here. So this box unwrapped is what this vector looks like. So this vector represents the unwrapped version of this box. Now when we unwrap vectors, if we go to our layers bar, you'll notice that we have 2 extra layers here. We've got unwrapped vectors drive rails, and if we double click on that, we can see we've got a vector along the top, we've got a vector along the bottom. So this is just useful if you don't have that geometry, or if that's the shape that you're wanting to create with the 2 rail sweep with these 2 rails, and obviously your cross section that the Unwrapper tool created. Now in our case, I actually don't want these vectors, as I'm restricting the shapes to this particular area here for the box, and this particular area here for the octagonal shape. So I'm actually going to look at deleting those. So we're just going to go and right click here. We're just going to delete this, and then we're just going to delete the data as well. You'll also notice here that we have a layer here called Unwrapped Vectors, and if I click on the page there, you'll see that my unwrapped vector has been positioned on this particular layer. Okay, so we're just going to switch off our components layer, 2 rail sweeps. We're also going to switch off the 2D pocket and the 3D boundary here. So we've just got the rotary profile with our unwrapped vectors. We're going to add in a new layer here, and we're just going to call this one rails. So we'll type that in. So we're going to call that one rails, and then we'll just change the color of that. We'll just make that turquoise color, make it the active layer, and then we'll start to create our drive rails for the box portion of our part. So to do that, we're simply just going to go into the polyline tool. Okay, so we're just going to snap to this point here, and then we're going to get to the bottom of our job like so. Come on over, we'll just wake this point up and follow that along. Click to accept that. And then what we can do is we can create a copy of that vertically. So with that selected, we're going to press Ctrl, Shift, followed by the letter V to create a copy of that vertically about the centre of our job, and there we have our 2 drive rails ready for us to use with the unwrapped vector and the 2-rail sweep. So let's just go into our layers bar, and we're going to switch on the visibility of our components layer. We're going to click on it to make it the active layer. As we're about to create a component, we want the grayscale to go onto that layer. So we're just going to tile our windows horizontally, and then we're going to go into the modeling tab into the 2-rail sweep form. So we're going to select our 2 vectors here and say use selection to transform them into drive rails, and then we're going to select our cross section here, and then we're simply going to go ahead and apply that to take a look at that. Okay, so it's not what I was expecting here. So we've got quite a large shape there, and the reason for that is because it's currently adding on top of our current composite model. So we're just going to go ahead and set the combine mode of that to merge, and we can see now it's blending in, and we've got that box shape there, and it's looking pretty good. And you can see that this has all been created with thanks to the Vector Unwrapper tool by taking that square vector and unwrapping it, and then we've used this as the cross section to sweep between the 2 rails to create this shape that we can see here. So we're going to give this one a name, so we'll just call this one box, and then we can simply press apply, and then we can close out there. So now we're going to look at creating the octagonal shape for this bulbous part of our spindle here. So if we go into our layers bar at the top here, we're just going to switch off the visibility of our components layer. And then what we're going to do is we're going to make the unwrapped vectors layer the active layer. And we can start to create our octagonal shapes, and we could look at unwrapping them. So let's just click into the 2D view there. We're just going to maximize that, and then we're going to use this option here to zoom active view to our drawing limits. So we're going to go into the drawing tab. We're going to look at using this tool, the draw polygon tool. So here we know that we need 8 sides for our shape, and then we need to specify the radius and the side length. Now in this case I'm not actually sure what the radius or the side length is here. Now I know the distance across the flat, so from this point to this point and this point to this point, which is from here to here, is at 0.75, so that's 1.5 across, and then from here to the highest point is 1.75, and so that's 3.5 in total. Remembering that we need to actually double that. So what I'm going to do is I'm just going to set a radius of 1 here, and then we could just go ahead and just press create and then close it. So we can take that, and then what we can do is we could just alter the size of this. We're going to go into the set selected object size form. We're going to ensure that we use the option here to link XY, so that we're scaling it in proportion in terms of the width and the height here. Okay, so we're going to look at creating the octagon for the highest part, which is going to be over here. Okay, so we need that to have a height of 3.5. And so you'll remember we measured from this point to this point at 1.75. So we need to ensure that we have an octagon that is 3.5. So here we just simply edit one of these values, and with link XY checked, it automatically fills out the opposite value. So here we can press apply, and that's that one done. Okay, so we can close out, and so we're pretty happy with the shape that we've got there for this part. But then what we need to do is we need to look at creating the smaller octagon. So we're just going to create a copy of this. So with that in selection mode, I'm going to hold down Control followed by the Alt key, and I'm just going to move that across. So Alt key just keeps that in line. And then with this vector, we can resize that. So we're going to go into the Set Selected Object Size here. So the distance between this point here and this point here was shown as 0.75, and so we need to double that, so it's going to be 1.5 across. So we just need to change the value there to 1.5, and we can go ahead, press apply, and then we can close out. So now we can look at unwrapping those vectors. So with the vector selected, let's go into the unwrap vector option. We're going to use the center of the contour. We want to simplify the unwrapped vectors, and we're going to go ahead and press apply. We can see that there. We're going to take this vector here, and we're going to do exactly the same there. Press apply, and we can see it's been added there. So we can close out, and we're just going to take this vector here, press 9 on the keyboard twice to rotate that, and then we'll just move that over to the right hand side over here. So this unwrapped vector represents the octagonal shape we want to apply to the highest point of this bulbous shape. This one, 9 and 9 again to rotate that, and we'll just move that below over here, and this unwrapped vector is going to represent the octagonal shape for the lowest parts of this bulbous shape that we're going to create here. So then what we can do is we could just go ahead and delete those vectors, and if we go into our layers bar, we can see again we have another layer created here from that unwrapping tool, and if we just select that, you can see those vectors there. We actually don't need them, so let's just delete this. We're going to delete that data also. Okay, so what we need to do now is we need to create our own rails. So we're creating rails that represent this point here to this point here. So let's go to our layers bar. Okay, so we're going to make the rails layer the active layer. And so to draw this one, we're going to go into the polyline tool. And I'm actually going to just snap to this point here and then snap to the end point there. And then with that, I'm going to select it, put it into transform mode, and then I'm just going to follow that up the y-axis until we meet the very bottom of our job. I can see the crosshair there. It's telling me we're snapping to the edge of our job, and I can click, and that will put that in position right there. And so just to be sure, let's just draw a line. We can see, yep, that definitely matches up there. And then let's just right click to come out, and then we'll just go back in, and then we'll just take that, and we can see that matches up there as well. So we'll just take that and just delete that. I don't need that there. Then what we can do is we can take that, Control Shift followed by the letter V to create a copy vertically. Okay, so what we're going to do is we are going to wrap the vectors, the unwrapped vectors, we're going to sweep between these two drive rails here. And so we're going to have a transition where it's going to go from the low octagon shape into the high octagon shape, back into the low octagon shape. So we need to ensure that where we position the highest drive rail, it matches up to the highest point that we have for the actual bulbous shape. So to help me out here, I'm actually going to draw a line where I'm going to snap to that highest point there. I'm just going to draw a line that goes all the way up like so. And we're going to take the bottom drive rail, I'm going to go into node edit mode. I'm just going to take that midpoint and I'm just going to snap that over. You can see I've got the crosshair, it's telling me we're snapping there. I'm going to put that there. And then we're going to take this one and we're going to do exactly the same. So it's snapping there at the line that we've drew, which represents the highest point of our octagonal shape. And then we can take that vector and delete that. We don't need it anymore. And so the idea is we're going to take these vectors and we're going to create a two rail sweep that's going to sweep from this shape to this shape, back into this shape, going across from left to right. Now, This time we're going to actually delete the legs off of our cross section, as we want the octagonal shape to actually add on top of this existing bulbous shape here. So to do that, we're just going to go into node edit mode. So press N on the keyboard, press D to delete this span, D to delete this span, and then D to delete this span over here, and D to delete this span there. We'll just press F to fit that to our screen. Now we have all of the vectors and our geometry ready for us to create our 2-rail sweep. So let's go into the modelling tab. I'm just going to switch off the main profile component. Let's just tile our windows, and then we're going to go into the 2-rail sweep form. So we're going to select our 2 vectors, and we're going to switch them to drive rails by using the use selection option. So we're going to start by applying the shallower profile here. So we're going to select that, and we're just going to click on the start point there. That's going to apply it all the way through like so. And then we're going to take this vector here. Now if we actually just maximize the 2D view and use the zoom to active limits option, we might be able to see this a little better. So we want this larger profile to be in line with the highest point of our bulbous shape. So that's why we moved the midpoint to a position that matches that for the actual rails. And you'll see that if I just drag my cursor along, I'm not clicking here, I'm just simply moving my cursor, you'll see that when I get to that node, you'll see that I'm displayed a node that looks like it's got a crosshair in the middle of it. That's the software's way of telling us we're actually snapping to a point here, and that's the node that we moved there. So if I click that in position there, that's going to apply that to the highest point. And so we've got our rails in position, so we're going from the shallower shape to the larger shape, and then we're going to go back to the shallower shape. So shallow, large, and then it's going to blend in to the shallow shape. And so then we could just go ahead and give that component a name. So we're going to call this one octagonal overlay, like so, and then we can simply press apply. And then if we take a look in the 3D view as well at that, okay, so it looks quite odd at the moment because we are creating very shallow shapes here. So if we take a look at this in the unwrapped view, we can see what that looks like. Okay, so it doesn't look a lot right now, but if we close out here and then if we switch on the main profile, we should be able to see how that looks. So we can see how that's adding on top there. So we've got our octagonal overlay adding on top of that bulbous shape, and then when we go into a wrapped view, this is what our part looks like. And so if we just switch off the octagonal overlay, you can just see just how shallow that is and how much difference it makes to the overall model. Okay, so now we're at a stage where we're ready to recalculate the toolpaths based on the new shapes that we've just created. So let's switch over to the toolpaths tab, and we'll just maximize the 3D view here. Now, because we've not created the new components outside of the existing vector boundaries that we specified when creating the original toolpaths, we should just be able to recalculate the toolpaths without editing them. And that will create the 3D roughing based on what the software can see now with the new shapes. The pockets will be the same as before, and the 3D finishing again will be calculated based on what it can see here. So here the software said that all the toolpaths were successfully recalculated, so we could go ahead and press OK, and then we can go into the preview toolpath form, can reset that preview, and then we can simply go ahead and preview all of our toolpaths. Okay, and so here it's looking pretty good, and we have a pretty good representation of what we would expect to see on our machine if we was to save these toolpaths out. And so to save your toolpaths out, you simply go over to the Save Toolpath option, To learn more about saving toolpaths, please take a look at the Saving Toolpath tutorial guide along with the Introduction to Rotary Wrap text tutorial, and we'll link both of those in the related videos section for this tutorial. So there is one other thing that we can do here, and that is saving out our spindle as an STL model. For example, if you wanted to import that into third-party software. So to do that, let's switch back over to our design commands, and then we're going to go over to this icon here where it says export visible model as an STL file. So here you just use the close sides option and then press triangulate, and there is your STL model ready to save out as an STL, which you can then import into third-party software. So that really concludes this tutorial on creating a 3D part for rotary machining. There are other tutorials available that cover 2D and 2.5D wrapped rotary machining and how to import and unwrap a 3D model for rotary machining. And you can find these videos in the related videos section for this tutorial on the tutorial browser. So let's go ahead and save this file. So we'll go to File, Save As, and then in the Project folder, we're just going to call this one Modeling a Spindle Wrapped Rotary Machining, and you can access that from the Project folder.